Let us see what principal quantum number is. We can take this as a model of an atom. Actually, this is for a hydrogen atom, but it is easy for us to imagine an atomic model like this. We have the protons and neutrons in the nucleus. Nucleus is positively charged and electrons going around in shells. A set of 4 quantum numbers are used to describe completely the movement and paths of each electron in an atom. Atomic orbitals are precisely distinguished by what are called quantum numbers. The first one is the principal quantum number, and it is represented by the letter n, small n. Actually, it identifies the shell or the energy level. It determines the size and to a large extent the energy of the orbital. And the principal quantum number n is a positive integer with value of n is equal to 1, 2, 3, etc. So when n is equal to 1, it represents the K shell. And this shell in fact has subshells, and that is represented by the letter S. And the subshell or the subshells will be having orbitals in between. Orbitals are regions or areas where you have the maximum probability or chance of finding an electron. So when n is equal to 1, that is the K shell, and it has one subshell S, and it will be having one orbital. Or orbital can be imagined as a room where you put electrons. One orbital can accommodate 2 electrons. Now, as we come down, n is equal to 2. When the principal quantum number is 2, it represents the shell L, and it will have the subshells S and P, and there will be n square number of orbitals. When n is equal to 2, n square is 4. So you will be having one S subshell and 3 orbitals in the P subshell. This is the 2s, that is one orbital of 2s, and then 2p, there are 3 orbitals. So altogether there will be 4 n square number of orbitals, 2 square. When n is equal to 3, it is the M shell. You will have the SPD subshells in it, and together there will be 9 orbitals because D subshell is having 5 orbitals in it. Similarly, n is equal to 4, you have the N shell and you have SPDF subshells, and 4 square number of orbitals. That is 1 S orbital, 1 orbital in the S subshell, 3 orbitals in the 4p subshell, 5 orbitals in the 4d subshell, and 7 orbitals in the 4f subshell. Together you will have 1 plus 3 plus 5 plus 7 equal to 16 orbitals. So all the orbitals of a given value of n constitute a single shell of the atom. Say if n is equal to 3, that is the principal quantum number representing the shell n. It will be having 3s, 3p and 3d subshells in it. So all the orbitals of a given value of n, all these orbitals will be having the same value as 3 as its principal quantum number. And when n increases, the number of allowed orbitals increase. That is what we saw now. Number of allowed orbitals is given by n square. So the principal quantum number, it identifies the shell or the energy level.